Hello, hi everyone. Welcome to the next video of this series. In this video, we are going to discuss some previous year questions of coordination compounds. Okay, so this is the chapter related to inorganic chemistry. And soon we are going to start with the organic chemistry. It's a matter of time. Okay, so let's start. Let's proceed in a systematic way. So first we are going to discuss the weightage of this topic, then syllabus with the help of the mind map, and then we will solve some previous year question. Okay, so who will get benefit from this video? Who knows the basic but unable to approach the problem, unable to solve the questions in less time, right? Who has NCERT level knowledge but wants to solve higher level of questions or good questions, right? And has taken coaching somewhere but the problem solving skill it is not clear. So this video is for those students, and if you are one of them, so please watch the video. Okay, now let's start. How to use this video? You have to revise complete chapter, you have to read the NCERT even, right? You have to revise your notes, then you are going to write important information related to the chapter, and then you will solve question, right? Next, what about the weightage? If I talk about the weightage, so weightage is around 6%. In some sense, we can say we can have two questions, and it is interrelated with other chapters also. So it's a good chapter, it's an easy chapter. You can score full marks, right? You can score full marks if the question is going to be from this topic. It's a very easy topic. Now, let's discuss the mind map. So in the coordination compounds, you should know the basic terms, right? Basic terms means what are metal ions, coordination number, ligands classification based on the denticity like monodentate, bidentate, tridentate, or we can say polydentate, flaxidentate ligands, ambidentate ligands, and chelating ligands, right? So you should revise this thing. Then you should know the IUPAC nomenclature, how to write down the name of the complex. So we have some basic rules, we have some standard rules. So you have to revise all those rules in order to write down the correct naming. Okay. Then we have some like types of complexes. Types of complexes like we can have homoleptic complexes and heteroleptic complexes, right? So you should know what are homoleptic and what are heteroleptic complexes. Then we have the theories related to the coordination compounds. So in the theories, we have Werner theory, right? The Werner theory is related with primary and secondary valency. Then we have VBT. In the VBT, we are going to find out the geometry, or we are predicting the geometry of the complexes. Then we have CFT, right? Crystal field theory. After that, we have one more topic that you have to study, that is the isomers or isomerism. So we have two types of isomers, structural isomers and stereoisomers. Structural isomers are further divided into ligand isomers, coordination, hydrate, linkage, ionization isomers, right? And in the stereoisomers you have geometrical isomers and optical isomers. So geometrical isomers and optical isomers, so you have to study for coordination number 4 and coordination number 6, right? So here these two coordination numbers, they are very important, so you have to revise all these topics, right? So all the topics are very simple, just go through the NCERT, just go through your notes. Okay, now I have divided all the questions of the coordination compounds into the 10 topics, right? So in the last one, we are going to discuss some question which is related to miscellaneous topic. In the miscellaneous one, we are going to discuss the question based on like monodentate, bidentate, and a polydentate, based on the basics. Or if we have some other question where the concept is different, so we are going to discuss that part in the miscellaneous questions. Okay, so now we are moving to the first type. So in the first type of question, we have questions related to nomenclature. Okay, so let's do that part. So question number 1 says the correct IUPAC name of PTBr2 PME3 whole 2. So see, what is Br? The name of Br ligand is, either you can write bromido or you can write bromo. Okay, bete. Then we have PME3. So see, PH3 is phosphine. So PME3 is trimethyl phosphine. So in the name of the ligand we have tri. We have tri. Now we have whole 2, right? Trimethylphosphine whole 2. So how to write? So see, we have to write in alphabetical order. So we write two ligands of Br. So we write dibromido, dibromido, or we can say dibromo, or bis. We are going to use bis because tri is already in the name of ligand. So bis trimethylphosphine, trimethylphosphine, bracket close. Then we have to write down the name of the metal, which is what? Platinum. Now we have to write down the oxidation number. And now how to calculate oxidation number? So let's say platinum oxidation number is X, bromine -1, so 2 minus 1, and PMe3, it's a compound, so it is going to be 0. So we get X is equal to +2. So we have to write oxidation number in terms of numeral. So answer is going to be dibromobis trimethylphosphine platinum 2. Okay, so answer is C. We have to use alphabetical order. One more thing, one more thing. If if complex is cation or metal is present in cationic complex, then there is no change in name of metal. Change in name of metal. Okay. If metal is present in anionic complex, then ATE as suffix is used to name the metal. Okay. So basically in this situation, here we have +2 charge, na? Platinum +2. So this is a part of cationic complex. So we are not going to change the name of the metal. Okay. Now, if you see this question is the IPAC name of K3CO C2O42. So this is C2O42 minus, this is what? Oxalato. We have to write oxalato. Oxalate hai, but we have to write oxalato. Right? Now 3, so we write trioxalato. Oxalato. Why? Because C2O42 minus whole 3. Okay, so first we write down the name of K3. So we are going to write potassium. Do not write tripotassium. It should be potassium. Okay, potassium, and then we write trioxalato, not tris. Oxalato. Up now, metal is the part of complex anion. Complex anion. How it is complex anion? See, because it dissociates into 3K plus CO C2O4 3 minus. So this is the part of complex anion. So we write cobaltate, trioxalato cobaltate. Clear? Now we have to write down what? Oxidation number. So suppose this is X. One oxalato is going to have -2 charge. So 3 minus 2 is equal to -3. So X minus 6 is equal to -3, which is equal to X is equal to +3. So we write 3. So on the basis of that, which answer is correct? So answer is going to be C. Potassium trioxalato cobaltate 3. Clear? Okay. So now we are moving to the next topic. So in this topic, we are going to discuss question related to Werner's theory. So in the Werner's theory, we have two types of valency, primary or ionizable valency, which actually tells the oxidation state of metal, and they are satisfied by negative ions. Okay, next, secondary valency, secondary, or we can say non-ionizable valency, and it tells us about the coordination number of metal. Okay, so we are going to discuss question related to this. So let's discuss question number 1. An octahedral complex with the formula COCl3 dot NH3. We have COCl3 dot NH3. Upon reaction with excess of AgNO3 solution gives 2 moles of AgCl. So excess of GNO3. So we get 2 moles of AgCl. Okay, fine. If we get 2 moles of AgCl, it means 2 Cl, right? They are present outside the coordination sphere. Then only they are going to be ionizable and we get 2 moles of AgCl precipitate. Okay, so one thing is clear. Now, consider the oxidation state of cobalt in the complex as X. The value of X plus N is. So, see, if we have 2Cl2 outside the coordination sphere, so how to write down the structure of complex or formula for complex? So, this is going to be CO, NH3, 5 and we write Cl. In that way, we can make coordination number equal to 6 बच्चे. ठीक है, coordination number equal to 6. So it means n value it is equal to 5 and oxidation state of cobalt is X. अब how to find out the oxidation state? The oxidation state is equal to the oxidation state, it is equal to the primary valency, 1 degree valency. So, or we can also find out oxidation state by X method. So, cobalt, let's take X, then 5 into 0, minus 1, minus 2, it is 0. So, X value, it is equal to plus 3. Okay, so oxidation state is 3 and it is X. We have to find out the value of X plus N. So, X plus N is equal to 5 plus 3, which is equal to 8. Which is equal to 8. So option D is the correct answer. Okay. Now let's do next question. Primary and secondary valency of cobalt in this complex. So we have the complex CO, NH3 whole 5, Cl and Cl2. Okay. So 2 degree valency, it is equal to coordination number and they are present inside the coordination sphere. Inside the coordination sphere. So inside the coordination sphere we have how many ligands? So total ligands here 5 NH3 and 1 Cl. So coordination number is equal to 6 बच्चे. ठीक है? So it is equal to 2 degree valency. Now we have to find out 1 degree valency. So 1 degree valency, they are responsible for the oxidation state. And oxidation state, if I want to find out the oxidation state of cobalt in this complex, so that is due to this Cl and these two Cl. So X plus 5 into 0 minus 1, then minus 2, it is 0. So X ka value is plus 3. Right, it is equal to oxidation number and that is equal to 1 degree valency. So basically what happens here, 1 chlorine, it has dual valency. It has dual valency. It also satisfies coordination number and it also satisfies oxidation number. Right. So answer is going to be, what is going to be the answer? 3 and 6. So option D is the correct answer. Okay. Option D is the correct answer. Clarity. That's it. Now let's do next question. So next question says with a correct formula of the compound which gives a white precipitate with BaCl2 solution but not with AgNO3 solution. A white precipitate. So white precipitate BaCl2, if we want to have white precipitate, so that is due to the formation of BaSO4 PPT है ना, तो BaSO4 is white in color. Not with AgNO3. So we can also have AgCl, na? AgCl precipitate which is white color. But question says we should get the white precipitate with BaCl2 but not with AgNO3. It means sulfate, sulfate should be present outside the coordination sphere. Coordination sphere. So just identify it. So here sulfate is present. The answer is this only, right? Here Br is present. So with AgNO3 we get AgBr yellow precipitate, pale yellow precipitate. Here Br is present. Again we get AgBr yellow precipitate. Here Cl is present. So here Cl is present. So we get AgCl white precipitate. White precipitate. So answer is option number A. Okay, now let's do next type of questions. So next type of questions are completely based on the VBT concept. So VBT actually predicts the geometry, right? Predicts the geometry of molecule. So here we are going to talk about hybridization of the metal ion. Right, so if we have coordination number equal to 4, so in coordination number 4 we have 2 sp3 and dsp2. So if the hybridization is sp3, then the geometry is tetrahedral, and if hybridization is dsp2, then the geometry is square planar. Okay, if we have coordination number 6, most common, they are coordination number 4 and coordination number 6. So if we have coordination number 6, so we have D2sp3. So D2sp3 means inner octahedral, right? Inner octahedral complex is going to be there. And if we have sp3d2, so it means outer octahedral complex. Okay, so geometry is going to be octahedral. If we have coordination number 5, so we can say that is going to be the trigonal bipyramidal. Trigonal bipyramidal. Okay, and if we have coordination number 3, then that is going to be trigonal planar. Trigonal planar. And if we have coordination number 2, so we can say that geometry is going to be linear. Okay, so we are going to find out the hybridization and then we are going to predict the geometry. So let's do the question number 1. So question number 1 says match list 1 with the list 2. In the list 1 we have some complexes and in the list 2 we have the hybridization. So it means we have to find out the correct hybridization. So how to find out the correct hybridization? So if we see A, so A is K2NiCN whole 4. So coordination number is 4, right? Coordination number is 4. It means it can be either sp3 or dsp2. So we have to check whether it is dsp2 or sp3. So how to check? So first we have to find out the oxidation number. So how to find out? 2 plus 1 potassium, then nickel X and cyanide minus 1. So that is equal to 0. So X is going to be beta plus 2. Now nickel is 28. So we write 3d8 4s2. Now nickel plus 2 is going to be 3d8. It means we have 8 electrons in 3d. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 3d. Now we have 4s and 4p. 4s and 4p, they are empty. Now we have to check Cn. So we know that Cn is going to be the strong field ligand, right? So if Cn is strong field ligand, then pairing is going to happen. And if pairing is going to happen, then this electron is paired with this electron, right? So after that, what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have one d orbital empty, one s and 3p empty. So what happens? This d, this s and this p, right? So they hybridize together to form dsp2, 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 dsp2 hybrid orbital, right? Or we can say Cn gives this electron to this dsp2. So similarly, it can give electron to this, this, and this. So hybridization is dsp2. So option A can be matched with 3, which is dsp2. Now check for NiCO4. NiCO4. So in B option, NiCO4. So oxidation state of nickel, it is 0 because carbonyl is a compound, right? So CO ka 0. So we write nickel 28, which is 3d8 4s2. 3d8 4s2. Now what happens? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 4s. Right. So now CO is also strong field ligand. So CO is also strong field ligand. And what are strong field ligands? How can you distinguish? So donor atom is going to be nitrogen or carbon. Right. So they are going to be the strong field ligand. So what happens? This is paired up and this is going to pair up. So now we have empty. Now we have empty what? 4s and 4p. So when we have empty 4s and 4p, so these orbitals they hybridize together to form 4sp3 hybrid orbital. That's why hybridization is going to be sp3. So this can be matched with option number 1, which is sp3. Now let us check, do we have this kind of option? So A is 3 and B is first. A is 3 and B is first, but that is true for option number B and D. So now we have to check one more, right? So let's check one more. C. So C is CONH3 whole 6 Cl3. CONH3 whole 6 Cl3. So first find out the oxidation number. So X plus 6 into 0 minus 3 is equal to 0 and X is plus 3. Okay. Cobalt is 27, 3d7, 4s2. So cobalt 3 plus is going to be how much? 3d6. So 3d6, how can we write? 1, 2, 3, 4, 5, 6. Okay, right. And now we have 4s and 4p. Now NH3 again, pairing is going to happen. So if pairing is going to happen, so we have empty D 1, 2, 3, 4, 5, 6, empty S and empty P. So we get D2sp3. So 6 D2sp3 hybrid orbital. Right. So here we can write ammonia. Here ammonia can give its electron. Here ammonia can give its electron. Here, here, here. So hybridization is D2sp3 and the geometry is inner octahedral. So C can be matched with fourth, which is D2sp3 beta. Right. So if C can be matched with fourth, so as per option, we have option number D as the correct answer. You can similarly check for the D1, right? So here F is going to be the weak field ligand, so no pairing is going to happen. And if there is no pairing, so what we write? So here this can be matched with option number 2, which is sp3d2. Okay, sp3d2. That's it. Now let's check for this one. PF5 and BRF5 both have sp3d hybridization. So let's check how to find hybridization of PF5 and BRF5. So we have to find out the steric number. So half number of electrons in central atom 5, number of monovalent atoms 5. So 10 upon 2, so steric number is 5, which is equivalent to sp3d hybridization. Okay, so this has sp3d. Now check for BRF5. So half bromine valence electron 7 and then we have 5. So this is going to be 6. So that is sp3d2 hybridization because steric number is 6. So that corresponds to the sp3d2 hybridization. We have discussed this thing in chemical bonding, right? So it means this statement is false. Now let's check for option number 2. Both SF6 and CONH3 whole 6 3 plus has sp3d2 hybridization. So let's check for SF6. So half 6 plus 6 monovalent, so again 6, so it is going to be sp3d2. So this is the true, but we have to check for this CONH3 whole 6 3 plus. So CONH3 whole 6 3 plus. So here cobalt is in plus 3 oxidation state. So cobalt is 27, so 3d7 4s2. So cobalt 3 plus is going to be 3d6. 3d6 1 2 3 4. 3, 4, 5, 6. Right. Now in presence of ammonia, what happened? In presence of ammonia, pairing is going to happen, right? So pairing happens. So if we are going to do pairing, so we have this 1, 2, 3, 4, 5, 6. Now empty D, S and P. So here we can write ammonia. Here ammonia can give its electron. Here ammonia can give its electron. Here ammonia can give its electron. here and here. So here hybridization is beta D2sp3 because inner d orbitals are involved, not sp3d2, right? So it means this statement is again false. So both statement 1 and 2, they are false. So we can mark option A as the correct answer. Okay. Now similarly, let's do the next question. We have to match. Okay, so this is a simple question, right? Memory based question. See, sp3, so tetrahedral, we have to match this with tetrahedral. So A is third, dsp2 square planar, so we have to match this with fourth. Then C, sp3d, sp3d trigonal bipyramidal, and sp3d2 octahedral. So if you see, so just see the correct option. A3, B4, C1, D2. So option B is going to be the correct answer. Right? Simple question, memory based question, right? Memory based question. Memory based question. Okay, bete. Now let's do the next question. If nickel 2 plus is replaced by platinum 2 plus in the complex, which of the following properties are expected to get changed? So the point is that if we have NiCl2 and Br2, अब now Cl or Br, right? अब issue what is this? देखो nickel, palladium and platinum. So nickel, palladium and platinum. So what is the oxidation state of nickel over here? So here we find X minus 2 is equal to minus 2, which is equal to X is equal to plus 2, right? Nickel is 3d8 4s2. Now nickel 2 plus is 3d8. So in 3d8 configuration, like palladium 4d8, है ना? And similarly for platinum and all. So what we are going to do over here, on moving down the group, tendency to form square planar complex increases. That's a rule, right? So palladium and platinum, they are going to form square planar. They are going to form square planar complexes no matter, or we can say irrespective to the nature of ligand. No matter what, they are going to form square planar complexes if the coordination number is 4, right? With the nickel and with nickel, what happens? If we have weak field ligand, then it forms tetrahedral complex, and in the presence of strong field ligand, it forms square planar complex. Okay. Up now in the question, we have Cl2 and Br2, both weak field ligand. So NiCl2Br2, that is 2 minus, right? So it's a it is going to have tetrahedral geometry. Do not check, but if you're going to check, you get the tetrahedral geometry. Let's check it. Chalo. Nickel 2 plus we have 3d8. ठीक है, तो 1 2 3 4 5 6 7 8. So pairing will not happen. So we have मतलब ligands can give its electron to S and P with it, right? Like Cl, Cl, Br, Br. So we have sp3 hybridization, right? But now what happens in presence of platinum? If we have now platinum, PtCl2Br2, right? So here we are going to form square planar, irrespective to the nature of ligand. So this is going to be square planar. Up now, the geometry changes? Yes, they change over. Which of the following properties are expected to get changed? So geometry? Yes. Now geometrical isomerism. Geometrical isomerism. So see, if we have tetrahedral geometry, so there is no concept of geometrical isomer. But if we have a square planar geometry, then we can say we can have a geometrical, this is going to be this form, and that is going to be the transform, similar to transform, right? So we can have geometrical isomers. Yes, we can have geometrical isomers. ठीक है, तो we are going to have 2. Okay, so this will change. Yes. Now optical isomers. See, this is optically inactive. Why it is optically inactive? Because nickel is not bonded to 4 different ligands. So this is optically inactive. We do not have the chiral center. No chiral center, right? And in square planar complex, because if this is the square planar thing, right? If this is the square planar, okay, bete, like this, suppose this is the square planar. That's a square planar thing, right? So if you pass a plane like this, right, it divides the molecule into two equal halves, right? So it means we have a plane of symmetry present. So this is also optically inactive. So part, optical isomerism part, it's not going to change. So no. What about magnetic properties? Yes, magnetic properties do change because when it is in tetrahedral, so we have two unpaired electrons, right? Two unpaired electrons. But in case of square planar part, as in square planar, this electron is paired up with this electron, so we have zero unpaired electron. So zero unpaired electron, so it means magnetic moment value is zero for square planar, and here magnetic moment value is around 2 point something. Understood? Clear? That's it. So this will also change. So based on the options, what is the correct answer? A, B, and D. That is going to be the correct answer. Okay. Now we are moving to the next question. So next question says, which of the following complex is octahedral, diamagnetic, and the most stable? Acha, now how to solve this question? Because simple task is that we just write down the geometry, right? You have to use a classical way. But you can also try something else, right? So if it is diamagnetic, means no unpaired electron, no unpaired electron. Octahedral means coordination number should be 6, and it says that it should be more stable, right? So the point is no unpaired electron, so this can happen in the presence of strong field ligand. So here to Cl a weak field ligand, so eliminate this. Right, water sometimes acts as strong field, sometimes acts as weak field ligand. So we have to check for sure. We have to apply another concept. Cn is a strong field ligand, so yes, we can check this. Right, NH3 strong field, so yes, we can check this. Right, bete. So अब issue is कि how to check this one. So see here oxidation state. If we find out the oxidation state, the cobalt oxidation state is +2. And here it is +3. Now in case of +2 and +3, in case of +2 and +3, so +3, it has small size. So small size means it can easily accept, or we can say electron deficient. So it can easily accept electrons from ligands, right? So it is going to be more stable in comparison to B1. Clarity, is it clear? Now, the third one, if we talk about nickel one, so here nickel is in +2 oxidation state. Okay, nickel is in +2 oxidation state. So here we have 3d7, here we have, okay, nickel is in +2 oxidation state now. So here we have 3d8. Okay, bete, here we have 3d8. So up see cobalt Cn minus, right? So cobalt we have to find out with respect to size order. Okay. So we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So here cobalt is in +3, nickel is in +2. So it means it is going to, it is more electron deficient. So if it is more electron deficient, so it can easily accept electron, easily accept electrons from ligands. So it forms more stable complex, right? So that is going to be the diamagnetic. Acha, or one more thing, let's check for nickel guys in that way, because cobalt hai, to cobalt. So cobalt is 27, which is 3d74s2. Now cobalt 3 plus, cobalt 3 plus, so that is going to be bete 3d 6. So we write 1, 2, 3, 4, 5, 6. Now what happened in presence of Cn? Pairing happens and we have D2sp3 hybridization. है ना? D2sp3 hybridization. So no unpaired electrons. But if we check for this one, nickel 2 plus bete, so nickel is 3d8 4s2 and nickel 2 plus is 3d8. So we write 1, 2, 3, 4, 5, 6, 7, 8. Right? So we can pair up, but what happens for coordination number 6, we should be having two empty d orbitals, which is not possible over here. So here what happens, these electrons, they are going to be in unpaired form and ligands donate its electron to s, p, 3 and d2. So here we get s, this is p and here d2, right? So 4s, 4b and 4d. So here we get outer octahedral complex, and outer octahedral complex, it is going to have sp3d2 hybridization. So due to the presence of two unpaired electrons, this is paramagnetic, right? So option C is going to be the correct answer. Understood how to find which one is more stable, which one is going to have octahedral, which one is going to have diamagnetic property or paramagnetic property, right? Okay. So now we are moving to the CFT part, which is the crystal field theory, right? So in the crystal field theory, what happens? Ligands are assumed to be the point charges, right? And when the ligand approaches to the metal for the formation of bond, for the formation of coordinate bond, then what happens? Degeneracy of d orbitals, they are going to change, that is going to change, and that results in the splitting, right? And splitting is going to happen, and that splitting in octahedral complex we call delta node, which is octahedral splitting, and in tetrahedral this is delta T, and in square planar it is delta SQ. So square planar is more than octahedral and then tetrahedral splitting. Okay, so that is the order. Let's do some questions based on the CFT. Number of complexes with even number of electrons in T2G orbitals is, right, with even number of electrons in T2G. So if T2G given, it means complex is octahedral, na? Octahedral. So what happens in octahedral complex? Like we have degenerate 5d orbitals, then splitting is going to happen. Okay, so we have T2G here and EG above. EG we have dx square y square and dz square. These are EG orbital. And in T2G we have dxy, dyz and dxz. So that is T2G. Now here we write minus 2 by 5 delta naught, which is minus 0.4 delta naught. And here we write plus 3 by 5 delta naught, or we can say plus 0.6 delta naught, and complete this difference is called octahedral splitting. Okay, so it means we have to fill the electron in terms of T2G and all. So first, how to do this? So we have Fe H2O6 2 plus. So here Fe is in plus 2 oxidation state, bachche. So Fe is what? 3d6 4s2, because atomic number is 26. So Fe plus 2 is 3d6. So now we have to fill the electron. So generally in the presence of water, you are not going to pair the electrons, right? So we write T2G, T2G 1, 2, 3, then no pairing 4, 5, 6, right? So this is T2G and this is E for this one. So in T2G we have 4 electrons, so even number of electrons. So here this is fine. Now let's check for next one, COH2O6 2 plus. So cobalt 27, so 3d7 4s2. Now cobalt 2 plus is going to be with a 3d7. So now we have to fill again T2G and EG 1, 2, 3, 4, 5, 6, 7. So here in T2G we have 5. So that is odd. So this is incorrect. Now we have to check COH2O6 3 plus. COH2O6 3 plus. So cobalt 27 3d7 4s2 bete. So cobalt 3 plus, it is going to be 3d 6. So we write T2G 1, 2, 3, 4, 5, 6. So here in T2G we have 4. So this is true. Now let's check for copper H2O6 2 plus. So copper H2O6 2 plus. So copper 29, which is 3D10 4s1, but copper 2 plus it is going to be 3D9 bete. ठीक है? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So in T2G we have 6. So that is even. So this is also true. Now let's check for the last one, CrH2O6 2 plus. CrH2O6 2 plus. So chromium 24 and the configuration is 3D54S1. So Cr2 plus is going to be 3D4. So we write T2G 1, 1, 2, 3 and Eg 4. Eg 1. Look, Eg में we have to put 4th electron. So here we have 3. So that's the odd one. So answer is going to be 3. Number of complexes with even number of electrons. So answer is going to be 3. Okay. Now let's do next question. So in the next question also we have to write down the electronic configuration in terms of T2 and E2. T2 and E2, that is the case with the tetrahedral complex. So in the tetrahedral complex, 1, 2, 3, 4, 5 degenerate. Then we have the splitting. We have what? Splitting. 1, 2, 3, 4, 5. So splitting. Now in tetrahedral, ligands approach to the metal through plane. So if they approach the metal through plane, then we have more repulsion in planar orbital. So here planar orbital dxy, dyz and dzx, they have more energy in comparison to dx square, y square and dz square. So this is above one is called T2 and below one is called E. It's not T2G and E, it is E. And that complete is delta T bete, tetrahedral splitting. So tetrahedral splitting is less than the octahedral splitting. Why? Because in octahedral we have 6 ligands and in tetrahedral we have 4 ligands. Less ligands, less repulsion. So less repulsion, less splitting. Understood? Now here this is minus 0.6 delta T and here we can write plus 0.4 delta T. We are going to use this concept later on, but I have discussed the concept over here. Okay. So now what happens? TiCl4. So here Ti is in plus 4. So scandium, titanium. So titanium is 22. So 3D2, 4s2. Now titanium plus 4 means 0. Everything is 0. 3D 0, 4 is 0. We do not have any electron in 3D. So the configuration is going to be E0 and T20. So A can be matched with option number 3. Okay, it can be matched with option number 3. Now let's check for this one. FeO4 2 minus, right? Which one? FeO4 2 minus. So we have FeO4 2 minus. So find out the oxidation state. X minus 8 is equal to minus 2. So X is plus 6. Iron 26, 3d6 4s2 and iron plus 6. So plus 6 means you have to remove 6 electrons. So that is going to be 3d2. So 3d2, so we have E2 and T2. So E2, we have 2 only, right? So 1, 2. So we can write E2, T2, 0. So E2, T2, 0. So B can be matched with option number 1. B can be matched with option number 1. Now let's check, can we match as per these options? So A answer is 3 and B answer is 1. A answer is 3 and B answer is 1. So we can have only one option, that is option number B. Right? But let's check for this one, third one. So third one is FeCl4 minus. So here X minus 4 is equal to minus 1, X is equal to plus 3. So iron 26, 3d6 4s2, iron plus 3, it is going to be 3d5. So let's put 1, 2, 3, 4, 5. So we get E2, T2, 3. Because pairing will not happen, right? Pairing nahi hoga. E2, T2, 3. Basically in tetrahedral 1, we do not have the concept of pairing. E2 and T2 3. So E2 and T2 3. So it means C can be matched with option number 4. Now let's check for D1. COCl4, it is minus 2 minus. So we write x minus 4 is equal to minus 2. So x is equal to plus 2. So cobalt 27, that is 3d7 4s2 beta, and cobalt plus 2 is going to be 3d7. Right? So let's put 1, 2, 3, 4, 5, 6, 7. So what do we write? E4T2 3. E4T2 3. So this can be matched with option number 2. Understood how to find out the configuration? Very good. Now let's do the next question. So next question says the correct order of A, B, C and D in terms of wave number of light absorbed. Wave number. So what is wave number? 1 by lambda. So if I say, and lambda is inversely proportional to frequency, so we can say wave number is directly proportional to frequency. And if we have more frequency, so we can say more splitting. More splitting. Right, so it means we have to check the order of splitting. We have to check the order of splitting. Delta splitting, either delta naught or delta T. So see, let's analyze it theoretically before doing the mathematic concept. So here we have 6 ligands, so here delta naught. Here we have 6 ligands, delta naught. Here we have 6 ligands, delta naught. And here we have 4 ligands, so delta T. So delta T is going to be less than delta naught. So D1 is going to have the least. D1 is going to have least. If you see the option, you can mark option number A. Right? But let's understand. Okay? So least is going to be D. Up now we have to check the order of delta naught. Hai na? We have to check what? Order of delta naught. Order of delta naught. So in B we have strong field ligand and cobalt is in +3. In C, we have 5 strong field and cobalt is in +3. And in A, we have 5 strong field, right? And cobalt is in +3 only. Cobalt is in +3. So oxidation state is same. So oxidation state is not involved in the, directly not involved in the delta naught. Right. Now what do we check? In the C1, we have H2O and in A1, we have Cl. So Cl is weak field in comparison to water, right? Cl is weak field in comparison to water. So if Cl is weak field in comparison to water, so what is going to be the order? Highest is going to be in B. Highest is going to be in B. All strong field ligand, right? Then in C, because water is better or strong field ligand in comparison to chlorine, then we have A. And the least one is D. So option number A is going to be the correct answer. Okay. Now let's do next question. The correct order of ligands arranged in increasing field strength. So this is basically a memory based. This is basically a memory based. So answer C is the correct option. And now let me tell you ki why the first one is wrong. So see, देखो ammonia तो strong है because nitrogen is the donor atom. Now here we have halogens. Here we have halogen, right? So F minus is going to be the better ligand. Why? Why it is going to be the better ligand? It has small size, right? It is smaller in size, so it can easily give its electron, right? It is smaller in size and it has negative charge, so it has to give its electron. Okay, better lead can give its electron. Okay, so in that way we are going to check. Here we have Cn, so Cn minus should be better ligand in comparison to ammonia. Okay, bete, clear? That's it. So otherwise it's a memory based completely. So C is going to be the correct answer. Now let's check next question. In an iron 3 complex, it means oxidation state of iron, it is +3. With the formula, this has no electron in the Eg orbital. No electron in the Eg orbital. The value of x plus y is, it means we have to find out the number of ligands. So first let's find out how much cyanide they are present. by the oxidation state formula. Oxidation state of iron is +3. Then we write x into 0. Then we write y minus 1 is equal to total charge. Right, so we get +3 minus y is equal to -1 and y is equal to 3 plus 1, which is equal to 4. It means value of y is equal to 4. Okay, y is equal to 4. Now no electron in Eg. Eg, it means they are saying that this complex should be octahedral complex. So if this complex is octahedral, if y is 4, then x ka value it should be 2 na bete. So x plus y, it is going to be the 6. We can solve in other way also, right? कि Eg है, so x plus y it is equal to the total coordination number. So total coordination number it is going to be 6. ठीक है बेटे, clear? That's it. Now let's do next question. CONH3 6 3 plus and COF 6 3 minus are respectively known as. So see, NH3 strong field ligand and F weak field ligand. So both are in +3 oxidation state. So cobalt 3d7 4s2. So cobalt plus 3 is equal to 3d6. So CONH3 6. Let me write on next page. CONH3 6 3 positive, and we have what bit is COF6 3 minus. So here we write 3d6 na, so 1 2 3 4 5 and 6. So here pairing happens, and after pairing we will have two empty d orbital after pairing. So here hybridization is D2sp3. So we get inner octahedral complex. ठीक है. अब now in COF6 1 2 3 4 5 6, again 3d6 only, but here no pairing, so no pairing. So here we can say we have sp3d2 complex. It is sp3d2 complex. Okay bete. So if it is sp3d2 complex, so spin paired means no spin, no unpaired electron, and spin free complex means we have unpaired electrons. So here we have 4 unpaired electrons now. So if we have 4 unpaired electrons, so this is going to be spin free complex, right? And this is going to be spin paired complex. Okay, clear? So option number B is going to be the correct answer. Now let's do next question. The complex with highest magnitude of crystal field splitting energy. Crystal field splitting energy means CFSE, right? The crystal field splitting energy. So see how to solve this. Dekho, there is always a way, right? You can find actual crystal field splitting energy, right? You can easily find out, but we can solve this theoretically also. So how to solve this? So here, this is here Fe plus 3, this is Mn plus 3, this is Cr plus 3, and this is titanium plus 3. So oxidation number they are same. ठीक है? Ligand same. Okay बच्चे, तो ligand same. अब now how to check, how to solve? So basically the one which has more delta node, which one has more delta node, right, is going to have more CFSE, right? So beta Fe is 3d6 4s2, so Fe3 plus is 3d5. Okay bete. Manganese is 3d5 4s2, so this is going to be 3d4. Chromium is 3d5 4s1, so chromium 3 plus is going to be how much? 3d4. 3d4. Now titanium is 3d2 4s2, so this is going to be 3d1 beta. ठीक है. अब now how to check this theoretically? How to check this? Because we have 3d4, right? And when we write down the electron in terms of T2G and EG, we are going to get same thing. So for chromium and manganese, if I'm going to write, so T2G 1, 2, 3, then EG4. Right, so we are going to have same CFSE ka value. Now highest magnitude of crystal field splitting energy, how to check? We have to check the radius. So if we check CR plus 3 and MN plus 3. Right, so Cr plus 3 and Mn plus 3, same oxidation state. Cr plus 3 and Mn plus 3, same oxidation state. But here, chromium is going to have least size or least radii. Least radii. Why it is going to have least radii? Due to maximum unpaired electrons. So we have to check chromium and manganese. Chromium is 3d5 4s1 beta, and here this is 3d5 4s2. So here 5 unpaired electrons and here we have 6 unpaired electrons. So number of unpaired electrons directly proportional to metallic bonding. And if metallic bonding is more, so we can say atomic size decreases. Also left to right, Z effective increases. But here we have to apply the concept of metallic bonding. So if metallic bonding increases, atomic size decreases due to also increase in the Z effective. But that is not the case with Mn. Mn में क्या है? We have less unpaired electron, so less metallic bonding in comparison to the chromium. Okay, Z effective also increases. But here we are adding the electrons in D. So if we add more electrons on D, so due to that we have more electron repulsion also. So here you have only two factor. You have to apply the two factor, what? Metallic bonding factor and the Z effective factor. So chromium is going to have least size. So here we have the maximum delta naught. If we have maximum delta naught, then the crystal field splitting energy is going to be more, because the number of electrons in T2G and EG in both, they are going to be same. Both going to be same. Now, here we have to calculate the CFSE magnitude, right? So that is given. So how to solve this? So let's solve. So we have A. So A is Cu2 plus. So copper is 3d10 4s1 बच्चे. So copper 2 plus is 3d9. So let's put 3d9. So 3d9 NH3 है, ammonia है, so it means pairing can happen. So we can say T2G and EG. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So we can fill electrons like this. Now how to solve this? Here we can write total CFSE value, right? We can write how much? 6 into minus 0.4 delta naught plus 3 into plus 0.6 delta naught. So this is minus 2.4 delta naught plus here 6 is 18, 1.8 delta naught, which we can write as कितना आ जाएगा ये? That is going to be minus 0.6 delta naught. ठीक है बेटे? अच्छा, what is the value of CFSE? So CFSE means number of electrons in T2G, then minus 0.4 delta naught plus number of electrons in EG, then plus 0.6 delta naught, and if we have pairing energy, then n dash p. We can also write this. So I am applying this fact only. ठीक है, तो we get minus 0.6. So A can be matched with option number 1. So we have two options, A and D. Now let's check B. So from the B1 we can find out the correct answer. So let's find out B1. B is what? TiH2O6 3 plus. TiH2O6 3 plus. So titanium is basically 3d2 4s2. So titanium 3 plus is going to be 3d1. So we have one electron in T2G, no, only T2G1. So how to find CFSE? 1 into minus 0.4 delta naught That's it. So this is minus 0.4 delta naught. So B can be matched with fourth. B can be matched with fourth. So if B can be matched with fourth, so it means option A is going to be the correct answer. Right? Rest you can solve at home. Simple question. Okay. Now let's do next question. Question says COCl NH3 2 plus absorbs at lower wavelength of light with respect to this. No. Here see H2O is strong field ligand in comparison to Cl, right? Comparison to Cl. So here delta node. More delta node means more frequency. More frequency means less wavelength. So this is false. Okay. Now question, it is because the wavelength of the light absorbed depends on the oxidation state of the metal. This is also true. Wavelength of the light absorbed is based upon the oxidation state. It is true. But not the correct explanation. So assertion A is false and reason we can say it is true, right? So A is false but R is true, right? So the point is if the metal ion has more oxidation number, then it results in more splitting. If metal ion has more oxidation number, then it results in more splitting. More oxidation number, more splitting. ठीक है? Not the correct explanation. Assertion is false. Now let's do this question. So here again we have to compare, right? Wavelength. So see, this is beta CO3 plus, this is CO3 plus, this is CO3 plus, and this is Cu2 plus. So here the coordination number is 4. So less splitting. So less splitting means less energy, and less energy means maximum lambda. So maximum lambda is given for 600. So it means D can be matched with fourth one. Clear? D can be matched with fourth one. Now rest oxidation state same. Now we have to check for strong field ligand and weak field ligand. Check this. So Cn better ligand, then ammonia and then Cl. So we have more splitting in C. Cn में more splitting. More splitting, more energy, less lambda. So less lambda is 310. It means C can be matched with first. Right, and then we have B, so B can be matched with second and A can be matched with third. So on the basis of that, what do we get? We can get A answer is 3, A answer is 3, B answer is second, C answer is first and D answer is fourth. Okay, so answer is going to be option number B. Clear? Now let's do next question. Which of the following will have maximum stabilization due to crystal field? Maximum stabilization means CFSE, maximum crystal field stabilization energy. So the one which have maximum delta naught, है ना? Maximum delta naught. So how to find out maximum? So this is Ti 3 plus, this is CO2 plus, this is CO 3 plus and CO plus 2. So here again coordination number 4 beta. So if we have coordination number 4, then less splitting, no? Less splitting. Now we have to check for C and B. C and B. Why? Because cobalt, in the case of cobalt, size is less, है ना? Size is less. अब C in cobalt 3 plus, more oxidation number, more splitting and more crystal field stabilization. So we can say option C is going to be the correct answer. We can do everything theoretically, right? Okay, fine. Okay, so we are moving to the next type. In this type, we are going to discuss some questions related to magnetic moment. So how to calculate magnetic moment, which is spin only magnetic moment, right? Spin only magnetic moment under root n plus 2. And the unit is Bohr magneton. We have discussed these type of question in the atomic structure also, where n is going to be the number of unpaired electrons. Okay, so now let's discuss question number 1 based upon this. Match list 1 with list 2. Okay, so we have CrNH3 whole 6, 3 positive. Okay, let's do this. CrNH3 6 and we have 3 positive. So here Cr is in plus 3. So chromium is 24, which is 3d5 4s1, and Cr plus 3, it is going to be bete kitna 3d3, right? 3d3. So we have 3 unpaired electrons. So how do we write the configuration? So this is going to be T2G3 only, because octahedral complex, so we can say T2G3. So if it is T2G3, so we have 3 unpaired electrons, and if we have 3 unpaired electrons, then magnetic moment is going to be 3 point something, right? Or we can say mu is equal to 3 plus 2. So 3 plus 2 means under root 15. So under root 15, 3 3 is a 9 karoge na. So you get 38.87. So A can be matched with option number 2, right? And now C, we have two options for that, B and D. And now let's check for B option in order to find out the correct answer, right? So we have NiCl4 2 minus. So NiCl4 2 minus. So this is Ni 2 positive. So nickel is 28, 3d8 4s2. Now Ni2 plus, that is going to be 3d8 bete. So 1 2 3 T. Acha, it's a tetrahedral. It's a tetrahedral, right? Because it's a weak field ligand. So it's a tetrahedral. So here we write E2 and T2. So 1 2 1 2 3. So we write 1 2 3 4 5 6 7 8. So we have two unpaired electrons. So if we have two unpaired electrons, so two unpaired electrons means magnetic moment is 2 point something bit. So B can be matched with option number 4. If B can be matched with option number 4, so we can take option number D is the correct answer. There is no need to solve further. Right, but you have to solve it that way, like I did for A and B, right? Okay. Now let's discuss next question basically. Which one of the following complexes will exhibit the least paramagnetic behavior? Least paramagnetic behavior means least unpaired electrons. Unpaired electrons. And what is paramagnetic behavior? What is paramagnetic? Weakly attracted towards magnetic field. Okay. So we have to find least number of unpaired electrons. So see, this is Fe plus 2. So this is 3d6. This is Mn plus 2. So this is 3d5. This is CO plus 2. So this is 3d7. This is Cr plus 2. So this is 3d4. Okay. Now we are going to write because H2S, so we are going to write T2G and EG1. So T2G and EG. So 1, 2, 3, 4, 5 and 6. So 4 unpaired electrons. Okay, 4 unpaired electrons. Now here 1, 2, 3, 4, 5. So here we have 5 unpaired electrons, bete. 5 unpaired electrons. Now we have 1, 2, 3, 4, 5, 6, 7. So here we have 3 unpaired electrons. 3 unpaired electrons. Now 3d4. 1, 2, 3, 4. So here we have 4 unpaired electrons. So least number of unpaired electron is in this. So option number C is the correct answer. Okay, option number C is the correct answer. Now let's do next question. Next question says a first row transition metal is in plus 2 oxidation state. Okay, first row, it means 3d series element, and has a spin only magnetic moment value is 3.86. So if magnetic moment value is 3.86, so it means number of unpaired electrons 3. So atomic number of the metal is, so it means 3 unpaired electrons. So see, scandium, titanium, vanadium 21, 22, 23. 3d1 4s2, 3d2 4s2, 3d3 4s2. So vanadium in plus 2, we have 3d3, it means 3 unpaired electrons. Okay, so we can say option number B is the correct answer. Okay, now let's do next question. Consider the following complex ions and you have to arrange This in correct order of spin only magnetic moment. How to solve? Simple na, Fe plus 3. This is vanadium plus 2 and this is iron plus 2. Fe plus 3 means 3d5. Fe plus 2 means 3d6 bete. And vanadium plus 2. Scandium, titanium, vanadium. So it is 3d3. Here we have 3 unpaired electron. In Fe plus 2 we have 1, 2, 3 T2 Gmain. Then 4, 5, 6. Right? So we have 4 unpaired electrons. Now in Fe plus 3, 3d5, T2G, 3 and Eg2. Okay, bete. T2G3, Eg2. Here we have only T2G3. Here we have T2G3 and Eg2. T2G4 and Eg2 here. So here we have 3, 4, 5 unpaired electrons. So highest is going to be in P. Then R, R and then Q. ठीक है? 5, then 4, then 3. Right? So P, R, Q. So option C is the correct answer. Okay. Next. Now we are moving to the next type of question, which is based on color of coordination compounds, and in that this is basically a memory based. This is memory based, but here we are going to use some part of the qualitative analysis. Qualitative analysis. Qualitative analysis. Like how to detect nitrogen, how to detect sulfur in the compound. So some complexes are going to be in that way. Okay, so let's do question number 1 on this. Match list 1 with list 2. So we have compounds and we have to match with the color. So see, just try to see the most common compound, right? So if you see this compound, this is what? Ammonium phosphomolybdate. Ammonium phosphomolybdate. And this compound is formed, right, when we detect phosphorus in the organic compound, right? So this is the result. This is used to detect phosphorus. Used to detect phosphorus in organic compound. And the color of this is canary yellow. Canary yellow. So it means D can be matched with option number 4. So now we have two options. Option number B and option number D. Up now, next compound. See, this is thiocyanate. And the color of this one is blood red. And this is formed when we have sulfur along with nitrogen in organic compound. It means this can be matched with option number 2. This can be matched with option number 2. C can be matched with option number 2. So see, here we have our answer. Here we have our answer. Option number D is going to be the correct answer. But let's check next thing. See, we have next, which color? FeCN5NOS. So again, violet color. This is violet color. Right, so this B can be matched with option number 1, and this can be matched with option number 3. So this is Prussian blue color, ferrocyanide, used to detect nitrogen. Used to detect nitrogen. Matlab when we detect nitrogen, detection of nitrogen, we have this compound, right? So this is the compound which is the result when we detect nitrogen in organic compounds. So this is completely memory based, right? So you have to learn it. The more you can learn, the more easily you can solve the question. Now let's do next question. Which of the following compounds shows color due to DD transition? DD transition. So it means we should be having electrons. Electrons must be present. Electrons must be present in D orbital. Electrons must be present in D orbital. Okay. So here we have Cr2O7 2 minus. So if we write down the oxidation state, the 2x minus 14 is equal to minus 2. So 2x is equal to plus 12 and x is equal to plus 6. What is chromium? It is 24 3d5 4s1. So chromium plus 6, 0. 3D 0, 4s 0. So D is 0. It means no DD transition. No DD transition. Check for copper sulfate. So here copper is in plus 2 oxidation state. So copper is 29, which is 3D10 4s1. Now copper plus 2, we have 3D9. So here we have D electrons. So DD transition is possible. And we know that color of copper sulfate is blue. Potassium dichromate color is orange. Color of KMnO4 is purple or magenta pink. So if we check for MnO4 minus, KMnO4, MnO4 minus, so x minus 8 is equal to minus 1, x is equal to plus 7. Manganese 25, which is 3D54s2. So Mn plus 7 is going to be 3D04s0. So no D electron. So no D electron, so no DD transition. So why? So what is the reason for the color? So that is ligand to metal charge transfer, LMCT. So due to LMCT, KMnO4 is colored. Same, K2Cr2O7 is colored due to LMCT, ligand to metal charge transfer. Same here, this is 2x plus, not 2x, plus 2 plus x minus 8 is equal to 0. So here x is plus 6. So here again, yellow color is due to ligand to metal charge transfer. Okay, that's it. So option B is going to be the answer. Okay, ji? Now let's do next question. Let's do next question. A solution of NiH2O6 2 plus is green in color, while a solution of NiCN4 2 minus is colorless. So how to solve this color? Not color. How to solve this question? So see, we have NiH2O6 2 plus. NiH2O6 2 plus and here NiCN4 2 minus. ठीक है बेटे, 2 minus. So nickel 2 plus and here also nickel 2 plus. So nickel 2 plus is 3D8. Here it is 3D8. So here we write 1, 2, 3, 4, 5, 6, 7, 8. So here we have two unpaired electrons and hybridization is going to be sp3d2. Why sp3d2? H2O is not a strong field ligand. So what happens here? S में 2 electrons from water, then P में 3 मतलब D से 6 electrons and then D में H2O, 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 H2O and H2O. So that is going to be sp3d2. Okay, now if we talk about NiCN4, so it's a strong field ligand and strong field ligand means square planar complex. So square planar complex means dsp2 hybridization. So it means we do not have any unpaired electron. Because in the presence of Cn, what happens? This electron is paired up and we have one d orbital empty, one s and then 2p. So here no unpaired electron. So no unpaired electron means no DD transition. No DD transition. Here we have unpaired electron. Unpaired electron. So we can say DD transition is there. And if DD transition is there, so color is there. Okay. So we can say solution of NiH2O whole 6 is green in color. True. NiCN4 2 minus is colorless. So this is also true. The statement 1 and 2 both are correct. So option B is the correct answer. Okay. Now let's do next question. A reagent which gives brilliant red precipitate with nickel ions. याद कर लो, memory based. It's very important with DMG, dimethyl glyoxal. DMG, right? DMG. तो DMG के साथ we have what? Ni2 plus. Then we have DMG. So it forms NiDMG2. Okay. So the color is rosy red precipitate. Rosy red precipitate, or we can say bright red precipitate. Okay, very important question. So option A is the correct answer. Now let's do next one. Again we have to understand it means you have to choose that complex whose color is known to you, right? So see, if we see option number C, that is MNO, and this is OH2. It means basic medium MNO, that is brown in color. How to memorize this? We have KMNO4. So KMNO4 minus, it is purple in color or magenta pink in color, right? So in acidic medium, it is converted to Mn2 plus, which is colorless, right? And in mild basic medium, it is converted to MnO2, which is brown in color. So from there we can memorize, right? In basic medium, right? So it is brown in color. So C can be matched with option number 1. So do we have any option like this? Yes, we have option number A and option number B. Now check next one. Okay, Fe4 FeCl6, that is used, basically that is after the presence of nitrogen in the organic compound, and the color is Prussian blue. So Prussian blue, yani D can be matched with 4th. Now on the basis of that, you can mark the correct option, which is B. Right? Now magnesium ammonium phosphate, that is white in color, bete. White in color. Right? Then K3CONO2 6 cobalt color hai. So that is yellow. Memory based, completely memory based. ठीक है बेटे. Now next, cobalt chloride when dissolved in water forms pink colored complex X, which has octahedral geometry. So basically cobalt chloride CuCl2, right? When dissolved in water, it forms pink colored complex, which is COH2O6, and that is 2 positive. It has octahedral geometry. So octahedral geometry. So we are going to write this one. And CO plus 2, it is pink in color, right? This is in the D and F block also. Now, the solution on treating with concentrated HCl. If you treat this with concentrated HCl, then what happens? You get COCl2, COCl4 basically, and minus 2. And the color is blue, and it is going to have tetrahedral geometry. Right? So answer is going to be option number A. ठीक है, याद करना है भाई, याद करना है, learn करना है, right? So COCl4 2 minus blue color tetrahedral geometry बेटे. Okay, now we are moving to the next type of question. In this type of question, we are going to discuss isomerism. So in this isomerism, we have two kinds, now structural isomerism, structural, and stereo isomerism. Okay, so here we have two types, geometrical isomers and optical isomers. So in coordination number 4, we can have, if the geometry is tetrahedral, so no GI, but we have optical isomers, right? If the metal is chiral, metal should be chiral, or metal is bonded to 4 different groups. Okay, if coordination number is 4, square planar, so we do not have optical isomers, but we do have geometrical isomers. Yes. And of coordination number 6, we have optical isomers. Yes, we can even have geometrical isomers. ठीक है, both. Right? Structure में we can have different types. So let's discuss the question. We will relate there only. Okay. So let's discuss question number 1. Given below are two statements. One is labeled as assertion A and other is labeled as reason R. Assertion A. Total number of geometrical isomers shown by this complex is 3. Is it true? Is it true? So see. Coordination number is 6. Why? Ethylene diamine, it is didentate. Or we can say bidentate ligand. है ना? It is what? Bidentate ligand. So is it 3? So let me write. So C. COCl, and then we have ethylene diamine, and we can write ethylene diamine like this. Okay bete, so this is the cis form, so we can have the mirror image to this one. ठीक है bete, we can have mirror image to this one. Now we can even have trans one, 1 2 En and En. So basically total number of isomers They are going to be 3. Total number of stereoisomers are going to be 3. But this says number of geometrical isomers. That is 2 only. Not 3. Not 3. So this is false. Now, COEN2 Cl2 complex has an octahedral geometry. Yes, right. It is true. It is true. Reason is true. So it means A is not correct, but R is correct. So option B is the correct answer. Now let's do the next question. The metal atom present in the complex MABXL. MABXL, it means MABXL involves sp3. That's why we have tetrahedral geometry. So the number of geometrical isomers. In tetrahedral, we do not have geometrical isomers. In square planar, we do have geometrical isomers. Here we can have the optical isomers, right? Here we can have the optical isomer. We can have the mirror image of this one. Okay, so geometrical isomers 0. So option A is the correct answer. Now let's do next question. Total number of stereoisomers for the complex this. So see, Cr, Cl, Br and oxalato. Oxalato is again bidentate bete, है ना? Oxalato is again bident. So we can have the mirror image of this one. Cl, Br, oxalato bete, and here oxalato. Clear? Total 3 minus and here total 3 minus. Up now we can have this form also. Oxalato, right? Oxalato, and this is Cl and this is Br. Up now, if you see this plane, if we have the plane like this, so it divides a molecule into two equal halves. See, it means plane of symmetry is present, and if plane of symmetry is present, so this is optically inactive. So optically inactive, it means we will have 3 isomer, 1, 2 and 3. We do not have the mirror image. So answer is going to be option number B, that is the 3. Clear? Okay. Now let's do next question. Which of the following complex has the possibility to exist as meridional isomer? So see, we have the fake and mer isomer. So in this we should be having this complex Ma3B3. That's it. So Ma3B3, right? So fake means MAAA, same, and then BBB, that is in octahedral one. And meridional MAAA, then BBB. So this is fake, this is more. Facial and meridional. So you have to basically compare the complex with this. So if we see, option number D is the correct answer. Okay, now let's do next question. The complex cation which has two isomers. Two isomers होने चाहिए. They should be having two isomers. So यहाँ पे if you see this, no geometrical isomer, no optical isomer. If you see this again, no geometrical, no optical. If you see this one, no geometrical, no optical, but we can have linkage isomer. Linkage isomer. Why we can have linkage isomer? Because we have the ambidentate ligand like NO2. So here linkage is from nitrogen. We can also write ONO. So linkage is from oxygen or oxygen lone pair, right? Or lone pair of oxygen is transferred to the empty orbital of metal. So here we have two isomer. What about this? No, nothing. No. So option C is the correct answer, right? Option C is the correct answer due to the presence of linkage isomerism. Now let's do next question. The Cl-CoCl bond values in a fake CONH3 Cl3 complex is R. So this is Cl, 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 and we have NH3, and here we have NH3. So COCl, right? So it means, just try to understand by this thing. Let me show you the octahedral geometry over here. So we are going to form this one. Okay, bete. Now I need one more atom. Just try to understand. Just see this thing only. This one. Right? So that is fake. So COCl. This is octahedral geometry. No, this is octahedral geometry. Okay. Now just try to analyze this one. Here we have 90 degree. With this one we have 90 degree. With this one we have 90 degree. Right? So even this one is going to have 90-degree angle. So we have only one kind of bond angle, and that bond angle it is equal to 90 degree. 90 degree, 90 degree, every bond angle CO, or we can say Cl, COCl, that is equal to 90 degree. Okay, clear? Okay. Now next one, chiral complex from the following is, which one is the chiral complex? So chiral complex means we should be having asymmetric metal ion. So we have cis PtCl2En2. So cis PtCl2En2 means PtCl, and this is En, and this is En. Okay, so this is first. Then we have transform of this one, Cl, Cl, then NH3, 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 NH3. Then we have PtCl2En2, PtCl2 and En2. That is the trans one, bete. And एक मिनट, let me write. This is option number A. This is option number B. This is option number C. And let me write option number D. So option number D is PT cis Cl Cl. Okay. Cl Cl NH3 and NH3, or we can also write in that way. This is cis now. So Cl Cl NH3 NH3, right? Up now we have to find out chiral complex from the following. So chiral complex means which can show optical isomers. Which can show optical isomers. So which one can show optical isomers? So see, here no optical isomers because this is the square pillar. If you see this one, so it is a plane of symmetry. This plane is the plane of symmetry. So no, optically inactive. Optically inactive. Similarly for this one, this is the plane of symmetry. So optically inactive. Inactive. But if you see this one, we can have mirror image of this one. So A complex is chiral because we can have the optical isomers of this one. Okay, that's it. Now we are moving to the next type of question. In this, we are going to discuss some questions which are related to the metal carbonyls. Right. So what are metal carbonyls? In which metal is bonded to CO. CO is the ligand, carbon monoxide, right? It is going to be the ligand, and the name of this ligand is the carbonyl. For example, we can have NiCO whole 4. Right, we can even have FeCO whole 5. So we are going to have some direct question on the basis of these complexes. Questions are basically on the structure of the metal carbonyls. Right, so you should know the structure of the metal carbonyl. So let's do the question number 1. The coordination geometry around the manganese in decacarbonyl dimanganese is. So how to solve this question? First we have to write down the formula for this, right? So let's write down this. So we are having Mn2CO whole 10, right? Mn2CO whole 10. So now see, manganese is what? 3d5 4s2. Okay. So we have two manganese now, 3d5 4s2. So how to write down the structure? 1, 2, 3, 4, and this is 4s. And here again for this one I am writing 1, 2, 3, 4, 5 and this. So 1, 2, 3, 4, 5 and then 4s2. 1, 2, 3, 4, 5 and 4s2. Right, now CO here. So in the presence of CO, pairing can happen, right? Pairing can happen. So for pairing, what happens? For pairing, what happens? One electron of this is going to pair up over here one electron of this is going to pair up over here, right? ठीक है, and one electron of this is going to pair up over here, ठीक है. Similarly we have pairing like this, and after pairing what do we have this thing, 1 2 3 4 5 6 and one electron here, then ds and p is empty, right? This is 3d, this is 4s, and this is 4p. Similarly for the below one, if we do the pairing, then similarly for the below one we have like this, 1 2 3 4 5 6 and this, and then s, then p. Now we have to put how many carbonyl? 10 carbonyl, right? So here देखो, first तो we can say कि we can have metal metal bond, right? So metal metal bond is generally present in metal carbonyls if we have two metals, right? So here we have metal metal bond, which is Mn bond, right? Now we have how many empty orbitals? 1 2 3 4 5. So one CO over here, one CO over here, one CO over here, one CO over here, one CO over here. Similarly, one CO over here, one CO over here, one CO over here, one CO over here, and one CO over here. Right? So if I draw the structure, so this is going to be like this, Mn, Mn, and that is going to be CO, 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 4 5 है ना, we have 4 5 bit. So we write 4 and this is 5. So this is CO, 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 CO. So this basically manganese forms how many bond? Total 6 bond now. So the geometry around manganese, that is going to be the octahedral, right? Geometry around this, that is going to be the octahedral. And if I want to form octahedral, so this is going to be like this, CO, 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 CO. And here Mn, CO, 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 CO. Now one metal metal bond. So we have the octahedral geometry, right? We have this octahedral geometry, right? Okay, bete, clear? That's it. Okay, so that's two octahedral. Now, similarly on this, if we see the structure, so in which one of the following metal carbonyl CO forms a bridge between metal? So that is for CO to CO halide, right? So CO to CO halide, it is going to be like this. We have CO, metal metal bond CO, then we have CO 1, 2, 3, 4, 5, 6, one bridge 7 and another bridge 8. Right, it's just you have to learn the structure of this. Mn2CO10 already discussed. If we talk about OS3CO whole 12, right? So that is going to be like this, OS, OS, OS. Now CO12, CO12. So every CO, 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 and CO. Same goes with ruthenium. ठीक है, so we have ना iron, ruthenium, osmium. तो same Ru, Ru, Ru. So 1 2 3 4, 1 2 3 4, 1 2 3 4. CO, 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 CO. It's easier to learn the structures, है ना? It's easy to learn the structure. CO, CO. ठीक है? That's it. So we have which? Option number D is the correct answer. Okay, now let's do next question. Low oxidation state of metals in their complexes are common when ligands. Low oxidation state of metals. It means metal is in low oxidation state. Suppose here it is in +2 and here it is in +3, right? And it can form bond with the ligand. So ligand hai. So basically, if we have M+3, if M+3 hai, so it can easily accept electrons from ligand in comparison to M+2. Why? Because M+3 is more electron deficient. So question says कि low oxidation state of metals in their complexes are common when ligands. So we have to discuss with respect to ligands. So ligands can give the electrons to the metal. If M plus 2, it means it has more electrons. And if it has more electrons, then it can give electrons to the empty orbitals of ligands. Right, so it means we can say when ligands have good pi accepting character. First, metal to ligand, sigma bond, metal to ligand, this is sigma bond, and then, sorry, ligand to metal sigma bond, and then metal to ligand pi bond. So when ligand has good pi accepting character, then that is going to happen. Now next, we are moving to the next type, and the next time we are going to discuss some uses. So uses as, so you have to learn it, just learn it, right? So Ziegler-Natta catalyst. So what is Ziegler-Natta catalyst? Titanium chloride and triethyl aluminium, and that is used in making high density polythene, right? So Ziegler-Natta catalyst. So we can match with option number 4. Now blood pigment. In the blood we have iron, so B can be matched with third. Wilkinson catalyst. So Wilkinson catalyst is rhodium. Yeah, this is triphenyl phosphine and this is chloride, right? So Wilkinson catalyst is this. So we can match this with rhodium, and vitamin B12 we have cobalt. So basically you have to learn it. So on the basis of this, which option is correct? Option A 4, B third, C first. Basically C is not first, C is first, and this is second. So option A is the correct answer. Okay. Now let's do the next question. Identify the incorrect pair. Haber process. So Haber process is correct. This is N2 plus H2, 2NH3. So we use iron as a catalyst. So this is correct, true. Polyethylene preparation already discussed. Ziegler-Natta catalyst we are going to use. That is true. Photography, yes. AGBR or AGCl we can use in photography. Okay, so this is also true. Rest, Wacker's process. So here we don't use PtCl2, we use PdCl2. And what happens in Wacker's process? Oxidation of alkenes, or we can say olefins. Oxidation in the presence of PdCl2 and CuCl to aldehyde. Suppose we have this, right, bete? So we can write this can be converted to double bond OH, aldehyde. So we produced carbonyl compound. So, okay, fine. So option D is the answer. Incorrect pair. Now let's do the next question. To inhibit the growth of tumor, identify the compound used for the following. So now this part is given a tumors wala part. This part is given in your NCERT chapter number 1, right? So basically cisplatin or coordination compounds of platinum we are going to use, right, to inhibit the growth of tumors. So cisplatin is what? PT, Cl, Cl, NH3 and NH3. That is cisplatin. So we can use this. EDTA nahi karenge. EDTA is generally used to soften water. Okay? And penicillamine. So generally we use this compound for as the antibiotic and all, we can use this, right? So we cannot use penicillamine to inhibit the growth of tumors. So answer is going to be B and D. Option C is the correct answer. Now we are moving to the last part. In the last part, we are going to discuss different questions. So just for first number question. So this is a part of the chemical bonding also. So N-trimethyl amine, this is trimethylamine and this is trimethyl phosphine, can act as ligands to form transition metal complexes. It is true. Why they can act as ligands? Because phosphorus has lone pair, even nitrogen has lone pair, right? Phosphorus has lone pair, even nitrogen has lone pair, so we can use. Now as nitrogen and phosphorus are from the same group, the nature of bonding of NCH3 and PCH3 is always same with transition. That is false. No, As nitrogen is more electronegative in comparison to phosphorus, so phosphorus can easily give its electron pair easily, right? So we cannot say the nature of bonding is going to be same. No, that is going to be false. So we can say statement 1 is correct, while the statement 2, that is going to be incorrect. So we can mark question statement, oh, we can mark option number 4. Statement 1 is correct, but statement 2 is incorrect. Okay. Now let's do the next question. Given below are two statements. So dimethyl glyoxime forms a six-membered covalent chelate when treated with the NiCl2 solution in presence of ammonium hydroxide. So this is not true. We can have the five-membered ring. We can have the five-membered ring over here. Prussian blue precipitate contains iron in both +2 and +3. Yes, it is true. So we have Fe4, FeCN whole 6, right? 3. Right, so this is basically Fe3 plus FeCN6 4 minus, right? Because ऐसे तो करेंगे Fe, so we write +3, FeCN6, so we write -4. So on cross multiplication we get this complex, right? So this is +3, and if I want to find out the oxidation state of this iron, so x minus 6 is equal to -4, so x is equal to +2. Right, so here what we can write? We can write key statement 1 is incorrect while statement 2 is false. So statement 1 is false, but statement 2 is true. Up statement 1, DMG, dimethyl glyoxime. So dimethyl CH3, oxime. In the oxime we have NOH, so we write double bond N, and that is O. Or here we can write double bond N, and that is O. Understood? अब जैसे Ni2 plus है, Ni2 plus है, so here nitrogen can form complex. So see, can you see this? 1, 2, 3, 4, 5. So we can have 5-membered ring बेटे. ठीक है? Similarly, we can form bond from here, double bond C, and here we can form N double bond C, and this is CH3, this is CH3, this is this, right? Now we can write OH, so we have hydrogen bonding over here, right? Here we write OH and here we write O minus, so we can have hydrogen bonding over here, right? So when we have this kind of complex where we have the 5-membered ring, so this complex is rosy red precipitate, brick red precipitate, right? Rosy red, right? That is used in order to detect nickel in the coordination compound. Now next, which of the following complex is homoleptic? Homoleptic. When we have same ligands, now homoleptic means same type of ligands. So same type of ligands, they are present in option number D. Only cyanide is present over here. So option D is the correct answer. Right? Now let's do next question. The correct statement from the following is: the strength of anionic ligands can be explained by crystal field theory. No, that's not true, right? It just said ki in the crystal field theory, it says that ki octahedral, as in octahedral geometry we have 6 ligands, so the splitting is going to be more, and we can say that degeneracy of d orbitals, that is going to be over, right? Right, so degeneracy cannot be maintained, right, when all 6 ligands approaches to the metal. So this is no, this is false. Next, valence bond theory does not give a quantitative interpretation of kinetic stability. It is true. Next, hybridization involved in NiCN4 2 minus complex is DsP2. It is true. Nickel 2 plus in 3D8 configuration in the presence of strong field ligand forms square planar. In the presence of weak field ligand, it forms tetrahedral. Now, number of possible isomers for PtCl2En2 2 plus is 1. Is it true? No. देखो see, PtCl2En2, En2 है ना? So, we have En like this, here En like this. Now Cl. So, this is the trans form bete. Then we can form the cis form like this. This is a cis form, right? And we can also form mirror image of this one. So total isomers 3. So correct statements from the following are option number B and C. So option number A is the correct answer. Okay. Now let's do next question. Ethane 1,2-diamine is a chelating ligand. Yes, true. Why? Because it forms ring. it forms ring. What is ethylene diamine or ethane diamine? NH2, CH2, CH2, and here we can say NH2. So either nitrogen can give its electron to metal pair, metal ion, and here. So it forms basically 5-membered ring. So it's a chelating ring. True. Next, metallic aluminium is produced by aluminium electrolysis of aluminium oxide in presence of cryolite. To see aluminium oxide, if you do electrolysis of aluminium oxide, you get aluminium solid and oxygen gases released, and this happens in the presence of cryolite Na3Alf6. So basically this is generally used. So here we use cryolite and all in order to decrease the melting point and in order to make the solution more conducting. So this is true. This is true. Cyanide ion is used as a ligand for leaching of silver. Yes, in the metallurgy process it is used. In the metallurgy process it is used. So this is the part of metallurgy. So it is difficult कि this type of question is going to come in 2025, but you can use the elimination method in order to choose the right answer. So yeah, this is the true one. This is true, right? So leaching होता है AgCN whole 2 minus. Phosphine act as a ligand in Wilkinson catalyst. Yeah, phosphine, but which one? Triphenyl phosphine. That acts as ligand in Wilkinson catalyst. Yes. Now, stability constant of Ca2 plus and Mg2 plus are similar with the Ag2 complexes? No, because size matters. No, size is different. If size is different, then the stability is going to be different, right? So which options are true? So we can say we have A is true, right? B is true and C is true. So we can see option number D is the correct answer. Okay. Now, next question. Yellow compound of lead chromate, PbCrO4, gets dissolved in hot concentrated NaOH. The product of lead formed is so PbCrO4. So we get PbOH4 2 minus plus Na2Cr4. We get this one. Here lead is in which oxidation state? X minus 4 is equal to minus 2 and X is equal to plus 2. And here, ठीक है? So here is also plus 2. ठीक है? So lead hydroxide. So we get what? Dianionic complex with coordination number 4. Yes, it is true. So generally complexes of coordination number 4 and coordination number 6 is possible. In general ways, they are more stable. Okay. Now let's discuss next question. The mismatch combination of chlorophyll, cobalt is present? No. In chlorophyll, magnesium is present. Water hardness? Yes. Treatment. Treatment of hard water में we can use EDTA. Treatment of hard water, we can use EDTA. Photography, can we use this? No, that is used in leaching of silver in the chemical separation, right? Matlab, if I want to separate silver from its ore, then we are going to do this process, but not photography. Photography में we can use AgCl and AgBr. Wilkinson, yes, this is true. Chelating ligand deep and yeah, this is true. ठीक है? This is also used for kidney stones. Kidney stones. ठीक है बेटे? So ये है. So choose a correct answer. So we get in correct answer. We have to choose correct answer. So we have mismatched combination. Mismatched. So mismatch they are A and C. That is going to be mismatch. Okay. Now let's do next question. The complex that dissolves in water. So how to solve this? So it means you have to identify the ligand, which can form hydrogen bonding with water. So if you see all the ligands, so we have this OH and OAC, है ना? CH3 C double bond O minus and OH. So they can form hydrogen bonding. So if they can form hydrogen bonding, so it means this complex is going to be soluble in water. So option number D. ठीक है? Now next question. The set which does not have ambidentate ligand. So see here NCS and NO2, they are ambidentate. Ambidentate. ONO and HCl. Here no ambidentate ligand, so this is true answer. Here ONO again ambidentate. Here SCN again ambidentate. So it means option B is the correct answer. Okay. Now let's do next question. Which of the following are example of double salt? So double salt है more salt, right? Or we can say K2 is a potash element. So these are double salt. B and D, they are complexes. So here we write CuNH3 whole 4. Here we write sulfate and then water. And for this one we can write K4FeCN whole 6. Right? So only B and D, they are going to be the correct answer. Not B and D, A and C. Option number D is the correct answer. Okay. Now let's do next question. Octahedral complexes of copper undergo structural distortion. Jahn-Taylor. Which one of the given copper complexes will show the maximum structural distortion? See what happens in Jahn-Taylor distortion. Ki suppose we have two orbitals like dx square y square and eg orbital, right? Up now suppose we have one electron in both, है ना? And we have 1 2 3 4 5 6 dxy dyz and dzx. ठीक है? So up now this is what 1 2 3 4 5 6 7 8. This is D8 configuration. Up now in D9 configuration I have to fill one electron, one extra electron. Up now if I fill one electron, so it can either go to dx square y square, even it can go to Eg, right? So extra one electron, it can either go to dx square y square or it can either go to Eg. ठीक है? So first of all, that happens in octahedral complexes. So first task is to find out ki which complex is the octahedral. Right. So if you see, so we have two octahedral complexes in the option A and B. ठीक है? Rest one are they octahedral? CuEn2 Cl2. Yeah, that is also octahedral and everything is octahedral, right? Fine. ठीक है बेटे? So the point is first octahedral complexes. Up now we have to check that if that one electron, if it goes to dx square y square, so here we have more repulsion. So if we have more repulsion, then what happen? dx square y square na, dx square y square, they are elongated. Yani dx square y square. So suppose we have octahedral geometry. So here we have z or dx square y square, they are elongated. If electron goes to dz square na, so dz square 1, they elongated. Understood? So this happens. So this is called Jahn-Taylor distortion. Jahn-Taylor distortion. If electron goes to dx square y square, then it happens, and then electron goes to dz square, then this is going to happen. Okay bete? ठीक है? Ab now, so the question is, which one of the given copper 2 complexes will show maximum structural distortion? So maximum structural distortion we have to see. So copper 2 plus. So copper 2 plus. So copper is what? 3d10, 4s1 and copper 2 plus is 3d9 configuration. So here होगा. So अब किस में सबसे ज़्यादा होगा? When? In which one we are going to have maximum distortion? So how can we say this? When we have same ligand, जैसे for example इधर H2O4 है, इधर En है, इधर H2O6 है, here En2 and Cl2, तो Cl2 is the weak field ligand, so let's do not consider weak field ligand, right? So En is strong field ligand, right? Here H2O4 है, but we have different ligands. So that is going to be more when we have symmetrical ligands, and a symmetrical ligand forms bond with the metal ion. So that is the case of Jahn-Taylor distortion. So here we can take option number A as the correct answer. So that's it. So we have completed almost all type of questions in the coordination compounds. Okay, so in the next video we are going to discuss D and F block questions. So that is also a memory based. So just try to see the video, right? And try to learn the answers of the questions. So if you like this video, then do write in a comment section, and you can also join the PracBee Revision program and everything, right? Everything related to the revision program, that is in the description box. Okay, bye. Take care. See you in the next video.